Hello everyone. This video is going to show you how to calculate a confidence interval. So we still have our baseball statistics and our random sample of 5 and our random sample of 10. So before we can do this, some things we need to look at are, we've got what are called critical z-scores. So we're going to need these depending on what confidence interval you want to look at. If you want to look at the 90th percentile, or a 90% confidence interval, you're going to use the z-score 1.645, 95% 1.96, and 99% 2.575. So now that you've got those, the first thing we need to do is calculate the standard error of the mean. So how we calculate that, it is on page 337 of your book. And what we're doing is we need to take the population standard deviation and, and divide it by the sample size square root, or the square root of the sample size. So what we're doing here is we need to take, again, our standard deviation of the population, which we've found down here. So there's my standard deviation. And what we're going to do is we are going to divide that by the square root, so we need that square root function of the total sample size. And here we've got a sample size of 5, so by the square root of 5, and we get a standard error of about 7. And we're just going to repeat that process with 10 instead of 5. So equals our standard deviation of about 15 divided by the square root of 10, because that is our sample size. And now we get about 5. So that's the difference in our standard error, and we need those to calculate our confidence intervals. So to calculate the upper bound, what you're going to do is you're following the steps on, I believe we're on page 339, and we need to take the sample mean. So let's do, this would be my upper bound. Let's do our, let's get a little bit more here. This will be my upper bound for the 5 sample. And then we'll have our 10 sample, just for a little more clarification. All right, so we are going to follow the page 339 in your book. So we're calculating an upper bound. So we're going to hit equals, and we want to start with our sample mean. So when we go back to our 5 sample, our mean is 75, so H3, and then we want to add onto that our critical z-score, which we're going to look at the 95th percentile, confidence interval of 95%, so we want that 1.96. And then after that, we need to multiply that z-score by our standard error of the mean that we have already calculated. So times that 7. So my upper bound is going to be 88.8%. And now we can just copy that formula and paste it into our lower bound, except we want to change the plus to a minus. So my upper bound is 88.8, my lower bound is about 61.1, and then my margin of error is the last thing that we want to calculate. And you can do that in 2 ways. Your margin of error, you can either calculate as taking your, z-score and multiplying it by your, why am I not thinking? Standard error of the mean, sorry. So you can take your z-score of 1.96 and multiply it by that standard error of the mean. That's 7, and that would give me my margin of error. Or another way you could do it is you could actually use the formula confidence.norm And then our alpha would be 0.05 because we want that 95th percent. So there's 5% left. That's my alpha. Then my standard deviation, we come back, find our standard deviation of our population. And then we look at our sample size next, which is 5. Type 5 in. And we get the same answer. It's a little bit different because of decimals and rounding between the Excel, but overall we're still going to get 13.86. So now we repeat that process with our 10 sample, our sample of 10. So we're going to take, again, equals our sample mean, which for our 10 sample was about 76.8. And then we are going to add our critical z-score of 1.96 times our standard error of the mean. And we get a 60 and 86. And we're going to copy and paste that formula, except for with a subtraction sign in it. Sorry about that. Change the symbol to subtract instead of add. And we get a lower bound of 66. And again, your margin of error, you can take your z-score and multiply it by your standard error of the mean. Or to check it, you can do that confidence.norm, alpha of 0.05 because we're doing 95%, standard deviation of the population is at 15.8, and then the sample size is 10. And you get the same margin of error there. So then what you should be looking at is that when we are increasing our sample size, we actually see that our confidence interval is decreasing. So our interval is getting smaller, which means we're getting a more precise estimate of the average, what are we looking at here? Sorry, home runs and hits. So the larger our sample size gets, the smaller our confidence interval should get because we're more confident that that our mean is going to be in that interval somewhere. And that's how you can find the upper bound and lower bound to find your confidence interval at a 95% confidence. If you want to do 90%, you just change that 0.96 to 0.1645. Same thing for the 99%, change it to 2.575.